In the following question, we need to uh, show that the following conditions are equivalent. The conditions that we are talking about is that number one, A is a subset of B. Number two, A minus B equals to phi. Number three, A union B equals to B itself. And number four, A intersection B equals to A. So what do we need to prove? That one, if and only if two, okay, that is they are equivalent. Let's try to do this first of all. So what do we need to prove? That A is a subset of B. Okay, we know this. Now we have to come down to the point that A minus B equals to phi. Now what does this imply? This implies A is a subset of B is same as saying that all elements, right, elements in A should be in B, right? So they are in B, okay? If all elements in A are in B, if all elements that are in B, all elements that are in A are in B, then what would the difference between A minus B be? Then what would be A minus B? Now what is A minus B? A minus B is all elements in A that are not in B, right? That's what is A minus B. But all the elements that are in A are in B. That means A minus B does not contain any element. There is no such element. There is no such element. Therefore, A minus B is phi, because there is no such element. Okay, so that's the reasoning. Now let's look at how second is same as the third statement, which is A minus B equals to phi. Okay, A minus B equals to phi is the same as A union B equals to B. Okay, so we have to look at A union B. Now what does this mean? A minus B. Now A minus B is phi. That means there is no element such that it is in A but not in B. Okay, so that means all elements in A are in B. Okay, for the same reason as we saw before. Now what is A union B? Let's look at what let me use a different color. Yeah, A union B. A union B means elements which are either in A or in B, right? So now what are the elements in A and B? Now whatever elements are there in A are also in B, right? Plus whatever more elements in B, right? So it should actually be equal to B. Because B already contains elements in A. Okay, so that's why it should be in B. So complete B is the union, right? Is the union. That is, sorry, A union B equals to B. There is, sorry, A union B equals to B. That is there. Now let's see how third is equivalent to the fourth. Now, third is A union B equals to B. If that is given to us, how do we reach the intersection? Now, what does this mean? A union B equals to B means that everything in A is already in B. So, all elements in A are in B. Okay, that's what it means. Now, this is what it means. We need to come down to intersection. We need to come down to intersection. What does intersection mean? Intersection. So whatever the common elements are, they form the intersection, right? So elements that are in A and B, both, okay? So they are in both. So that means, so what are the elements which are there in both? All the elements of A are in both, right? So A intersection B should, in this kind of situation, should equal to A, okay? So now, because one implies, one is same as, what have we proved here? So we have proved that 1 if and only if 2, 2 if and only if 3, 3 if and only if 4. So we have 4 equivalent statements. Thank you. Okay, the question with us is that there are 3 sets X, Y, and Z such that X union Y equals to X union Z and X intersection Y is equal to X intersection Z. So what do we have? What is given to us is that X union Y equals to X union Z and X intersection Y equals to X intersection Z. What we need to prove is that Y equals Z. Okay, Y equals to Z. So how do we proceed? Let's start with what is given to us. X union Y equals to X union Z is given to us. Okay, if I take intersection with Z on both the sides, it will still remain equated. So let's do that. So X union Y intersection Z will equal to X union Z intersection Z. Okay, now X union Y is, now this part, X union Y intersection Z. Now this equals to X intersection Z union Y intersection Z. Okay, so we have, this implies X intersection Z union Y intersection Z equals to, now this thing, this part, this actually equals to X union Z intersection Z actually equals to Z itself, Y. Just see, if this is Y, this is this is X, this is Z. Okay, so the union is complete this portion, right? Both Z and Y involved in it. Now when you take intersection of this with Z, the only thing that would remain is Z itself. So that's why this actually equals to Z itself. So here you have Z. Okay, now this implies, what is X intersection Z? X intersection Z is actually equal to X intersection Y, and here you have Y intersection Z, right? Now that means this is the distributed manner of writing it, we can write it as X union Z intersection with Y. Okay, intersection with Y. This is because X intersection Y equals to X intersection Z, right? So this is because of that reason. Now, this is equivalent to this. Now, because again X union Z actually equals to Y union Z. Okay, so you can write this as Y union Z. Y union Z intersection Y. Intersection Y. Now, just similar to the reasoning before, we gave Y union Z intersection Y will actually equal to Y. Why? Because see, again, if this is Y, this is Z. Now, so the union contains complete this. But if you take intersection with Y, the only part that remains is Y. So this implies Y equals to Z. Okay, and we have proved what we wanted to. Okay, in the question we're given that there is a committee. 50 people out of that committee speak English and 20 speak French. Okay, 20 speak French and 10 can speak both the languages. Now we need to find out how many people speak at least one of these language. So what is given to us? Let me just write down what is given to us. Given to us is that, first of all, let's denote E as the symbol for the set of people who speak English, and F set of people who speak French. Okay, so what is given to us? We are given that number of people who speak English is 50, number of people who speak French is 20, and number of people who can speak both, that is the intersection, is 10. What do we need to find out? We need to find how many people speak at least one of the two languages. That means how many people are actually there. That's what we have to find out. We need to find out how many people can at least speak at least one of these languages. So we need to find out what is E union F. Okay, now by cardinal property, sets have a cardinal property. So by that, you know that N E union F equals to NE plus NF minus NE intersection F. Okay, so that equals 250 plus 20 minus 10, which equals to 70 minus 10, that equals to 60. So the total number of people in the committee, 60 can speak at least one of these languages, right?